다 이차디 나로라 림바 디주 고여스로아 디무슨자 당보 이차 카치기로아 카치니 단다델 타다지도아 타다델 페고레스.
So this page will open. What you have to do is go to the latest release.
다디 타다델 네윈디 아니 타쇼 사와지 카치기도아 타갸 안디 나로라 latest release le 디가라 능고레스.
Then we click on this. Scroll down. Whoever has Mac will download this. Whoever has Windows can download any one of this. I would say go with this one.
지난다디 슈고 카체사 위전에 마 월라 페바이나스 데라 아니 타다니도아 아니 쿠슈다징기 로레요나 아니 니바디 간라 페로체스 라 아니 기공기디나 디 숨바디 갈 페로체스 마 파블레치사기 로레체라.
What you will get somewhere is something like this interspec, which is now will be if you have successfully downloaded, this is something that will be on in one of your applications.
데네 파기디 넨사베 젤라 닌체 이레라 파리치에기 닌체디 밍라 interspec 그레스 라 안디나게 수파치기나 파리치사기 디나레 용고라.
So this is what they have to do during their lunch break. So
on the logle susu logle chasang gangla nyenche di ma phable nang ro nas.
Okay, so now I will start the talk.
And then they have to bring it in the afternoon? Do
Yes, with their laptops. It will be on their laptop. So.
And chekogi zindala pepti nam peroches.
So now we have seen what natural radiations are, right? It's in the nature, we cannot get rid of it. So it's called background radiation because it will always be there for us.
Chizata rangjung ki ani keto kordi ngodu shubarwa di ni ngazu rangjung koyu nalo yoba res pa meba suye ke yo ma res di imbosun zang kyabjong ki keto slani ming dustagi yo res.
So now we also have man-made radiation. These are artificial radiation, right, which we produce. Like some of these radiations are also produced in nuclear reactors, the fusion reactions, right? You get radioactive isotopes and all that, right? And then it undergoes neutron. Remember yesterday we saw neutrons are emitted. The free neutrons can be radioactive.
아니 가자 슈바나 신체네 단다 아니 데뉴트린체스 라니 주르고다 nuclear reactors 라 간제 데듀레소 누발렌체라 디 데뉴트린체 나로라 아니 기규르기 다 가조 카르소레 탑조 중에 값수 아니 왜 치토 치기래라 아니 디 버두 망고 치토 치기라 딘데기 버두도조 버두 개간네 와도조 상마 제로랑 신체 레스.
And even like the X-ray machines, when you have, like, let's say you have broken your bones, you go to get your X-ray done. So these X-rays are also made, right, produced by bombarding a radiation with some target atom. I think it's molybdenum, if I'm not wrong, I'm not sure. So then that will produce X-rays. And so this is what we saw. We see, like, when you have an X-ray, there is some white patches and one black, right? Some black. White is when the X-rays are absorbed and then they get the image like white. That black area, that means X-rays just escaped.
다나시 단당아주 lokbar기 취재도주 낭로라야 이케드윈 치겨와 아니 디 낭로라 더 케드윈 치기 규림 디 낭로라 페제 치기 페제 듀텐디 아니 몰립디남세 디 페제 임바여스 다디 카르소레 lok바도주이나 로두기 아니 카르소레 마레 데두기 탈라유베 아니 로두기 림바 디네네 용고라 lokbar 제자 건조 덴데기 듀텐데라 안 듀셴바지기 코 딜라 갸발라 테네 로두주야 누바 고말라도 데네 마사윤디 카르소레 lok바 기든치고 어바 덴데기 lok바디다 아주 ngobo 가리네 야코 땅와이나 아니 리베기 아니 코디 로두 lok바 토세디 망고지 숭루레스 아니 송사 강요 바데라 가부 통그레스 데네 코 마송와 진에 갑두 로샤와이나 아니 파게디 가서 진쇼데 갈라 나고 통그레스 안디네게 토네 아니 코 파르디 아니 차용고레스.
So these are all artificially or man-made radiations, right? And then when you make a nuclear weapon, right? So like some country like China or some, they are testing their atomic weapons, right? That's also that release radioactive material, because that's an uncontrolled reaction when you have atomic bomb explosion, right? So what happens in these kind of atomic weapons, lot of radioactive material is released, and this is called the fallout into the air.
지다다 든주 미스여바체 아니 데네야 미스여베 케트나로 카직 다 뒤된 천자로 속바로와 아니 천자기 토네 천자디스 아니 쳐다체we 갑소도 고 천자디 떠르고요와 아니 떠르웨 슐도 아니 케트랑 신쟁기 제 망부 시우직 아니 고 카잉나 레 코리우나 르 용고요 레스 제상 편침부 시우직마 용고요 다 카르소레 건조기 칙 fallout 식도 카르소레 건조 데플롱체바 슬랍 제 망고 시우지 케르랑 신생이 제
usually what they see is cesium 137 and beryllium 7 from these kind of atomic weapons, right? So what happens is they settle on the ground. This radioactivity, they settle into the ground, and it's incorporated into the environment because it's on the ground now.
딘데게다 다 당보 판나래 여바이네 아니 사시갈 마 파블릭로와 아니 사실라 팝 아니 코리오기다 로샤그레스.
So the fallout with short half-lives, okay, which is not, I have not taught you about short half-lives, so that's okay, I have to teach you tomorrow. But some of them will decay away completely, so that's not a concern. But some of the fallouts will stay for years and years. And that can be dangerous because that can develop cancer in people and all the other things. So that's where, if it stays on the ground forever, that's bad.
제가 사실을 홍샤 결혼한 신경이 제도 체세 뒤에 tundu res 지난 체세 뒤에 통동이 거디 산이 슈긴스 언데 임바이나 그 요구지 코나 디 제도 res 그 결혼한 신기 다 제도 아니 뒤에 tundu 지나로라 결혼한 신제 마임바 차도 res 라디 무슨 디 내가 싫어요 말 내가 이내 릭직 유정부 고 하데인데요 레스트 고 무튜니 아니 디니니 개로 깨고와 안 딜라테네 디 카르소레 냥가 첨부 차르고 레스.
So also like in nuclear power plant, if there is an accident, so recently we know about the Ukraine and Russia war. They attacked on the nuclear power plant in Ukraine, right, Russia? So when they attacked, lot of radioactivity was released. This was still small, but in 1980s, there was a nuclear power plant accident. No one attacked on anything, but there was something just malfunction in the nuclear power plant itself. That released lot of radioactivity. That was the Chernobyl nuclear power plant in Ukraine.
다나시야 간주 미스베 개로 릭직로와 단다 카르소레 아니 데뉴 소다세고라 데뉴 카르소레 데듀르 중원 누바 아니 소사게다 소다 첨부 된데라 아니 고차 중원데 라 아니 망골로요 레스 다 녀차 단다 유크레인다 우르수니마 제베갑소 유크레인 데뉴 소다 된데라 다 파르제 슈네 아코 카르소레 개로 망고 다 치로치야 중요레라 라 딜레 두 가지 애니고마 된다 우르수 나레 초노빌 라이디 데라 아니 중네 디디 애니 코리오 나로라 게토랑 신진게 제 망고 시우직다 바 캡도레스.
And that nuclear fallout, that radioactivity that settled on the ground, it's still decaying. It's so long, the half-life, it's still there and it's still decaying. And it was not just in Ukraine, it got spread in all the parts of Europe. So don't think if an accident happened here with this kind of radioactivity, it will just stay in one location. It spreads in the air.
다 디디가수 아니 중샤베 다 단다 코유나라 여바디 단도엘 하데요 레스 라 로망부제 아니 딘데 중두 잠발 거자 중사코라 사제 주고라 아니 단다디 게로라 신정기 제디 아니 가수래 사대 디 마레스 라 고찹루고레스 안 찹네 단데 차라 다디 우르수나라 유럽 기 사자 망구시우질라 안디 찹데레스.
So you can imagine so much activity was, radioactivity was released that many people died just in few days after that accident. It was so high, like not just becquerel, gigabecquerels I'm talking about. It's really high radioactivity, and many people developed cancer.
다디 고차디 중에 아니 간소래 개로랑 신체기 제디 하장기 표현신부 아니 중발라데 중요레스티디로와 딜라테네 니마카시 나로라 미망고 시우지 통로야다 안테네 가르소네 미망고 시우지라다 제네 중야 어디데 아니 내가 중요레스.
So he is a scientist at Snow Lab from Ukraine, Oleg Shekvorets, and when this incident happened, he was working in a science lab, and he's a very good scientist who looks for gammas and everything, gamma intensities. So he was in this helicopter when this Chernobyl nuclear power plant accident happened. He was in this, he flew in this helicopter around the site to install a gamma counter detector there and measure the radioactivity coming out from that reactor or the, the close by areas every single day. And he spent like 1,200 hours of flight time to measure the radioactivity.
Tanda di theory but gyala Quran chale nasa ki taji khan Snow Lab ni phage chale nange theory bachi res Ukraine ki michi re toa chizanda Chernobyl ki tanda duden ki khocha di chungwe kapsu ro karsure khocha chungwe kapsu ani ta khonzo geto khasu yunggo do senje chela ani Quran tanda di namru di helicopter insarwa tebu namru di nanglo la chuze jigdong ni gas chin ro ani phage karsure ngazo geto jinche ki thuja do zo pha zo zu ne ani senje do ani cheyores.
So all I'm showing you all these things is because when lot of radioactivity is released, it can be dangerous. You can even die from that radioactivity and develop cancer over, years. So when he was going there, like the guy sitting here, when they go, they put some protective clothes and they don't stay there for long time. They just take the readings and come back.
제가 딘데기 개토도 수고를 포에 디베 년가 첨부 시오로와 아니 이나야다 딘데네다 중도 건조 천재 제고로와 딘디 답하게 로도 애니믹스에 돌로 그냥 딘데요레 두주큰 안파게 사실에 권유령부 되게 말레스 축축제 파게 천재 디체 아니 로용야 디치고 레스.
So now just to summarize, what we have learned is X-rays and gamma rays will easily penetrate the human body, right? So they are also used for diagnostic purposes to kill the cancerous cells. Alphas and betas lose energy within a short distance. They cannot travel far, right? And if it is outside, alphas will be completely stopped just with clothes, right? And so gamma radiation is easy to observe because it will just pass through our body and the detector can detect it.
제가 초동체바이나 라 아니 트로세르탄다 X 트로세르다 아니 가마 트로세르도 저기 ngazu lubu나로 레라부치니 심두레스 아니 디 무슨자 코멘제기 랑레나로레 페제 제기어레스 데네 아니 조야기 탑람라에 페제 제기어레스 다 알파다 비타기 뒤도 조이나 장다 링부시라 드투마레스 라 장다 퉁두니 코랑기 누바디 라드에 라 아니 아주 수고도 주나로라 아니 주투마레스 라 투글로라 소고도 주 까기어라 이나야 가마기 토세도위나 아주 수고나로라 레라부지니 아니 심주체네 아니 제투구여레스.
So also, like we have learned, if radiation is a radioactive sources on the ground or outside, alphas and betas will be stopped, gamma can still enter. If the source is inside the body, alpha and beta are completely absorbed because they don't travel much. We have seen how much they can penetrate, 1 or 2 centimeter, right? Something like that. So whereas a certain fraction of gamma radiation, so some of these, where this morning we discussed, some of the gamma radiation will deposit some of its energy, rest, it will just go out.
Tanda di Kerora Shinjengi, any Zeduzugi, Jungungsura, Jungundi, Nazu Lubu Chilola Yoba, Penasashida, Doda, Dine Yobaina, Dine Tembe, any Alphagi, Ketore, Bidagi, Keroduzuina, Nazu Lung Nalo, Shira, Dretu Marilla, Naranzu Tulo, Kagres. The Gamma Troseduzu, Nubachimbu Yobosunza, Nazu Sugunala, Sim to your rest, Ra. That dinda di Kedugi Jungung Jera, Jungung di Naranzu Lubuna Lebaina, Alpha the Beta Jungung to Lubuna Lebaina, and the Zedigi Kid. Do you do Sugun Anglola, any Nazugi Puntuta, Tabunduzula, called Tim Drone, Ra, Timiadi, Yungu rest, Nuki Yungu rest. Imbaina Gamarina, Gamma to say to the Tangi Shubanashineko. Dejo chita rimbasum yorwa ani rigji nubatos chik ko dutendi late ne koran thendo yada andi gama ina ko nubachimbu yobasunza ani suguna lola khas chashe chik absorb che simba che ani shemba thendo yadi yungures.
And if you eat food that contains radioactive compounds, they can be easily measured if gamma rays are emitted, right? So we can have the gamma detectors. Example, it is possible to measure the radioactivity that is inside the animals and humans which have eaten food containing. So if there was a nuclear fallout, like nuclear accident, the fallout, it's on the ground, and if they eat food from that place, they can get that radioactivity in their body. Doesn't matter, human or animals, anyone. If you eat that animal, you're getting that radioactivity as well.
The covering Azuki say in Anglola, any Kerala Shinjing Zay Yobache, any the Nazusane, Sugunanglola, Gama Lebaina, Gama Duzu, any Chilola, Tujegi, any Sung to Grace, Benachashava in other Tanda Kochat in the Chungwe Kapsu, any Chumushu Gora, any D Kala than the Union Azusuguna Droaina, Konzugi Mutune, any Keto Kegi. Karine, any Gamma Tosedo Duzuina, Sugune March, and also Trijanal J2 Yungres.
So, I'm not sure if you know, in Japan there was a Fukushima reactor. There is a Fukushima reactor, and I don't remember the year, but there was an earthquake, the tsunami, and that also triggered these reactors, and something malfunctioned. The reactors were shut down. Lot of radioactivity was released, and there was fallout that was incorporated into the environment. So all the fish there in the lakes and everything, they absorb that radioactivity. So if you have eaten fish from that lake area or close by, you have radioactivity in you. So this is just some of the samples that the government sent us at Snow Lab, and I analyzed it. This was a dried fish sample. They collected the fish, dried it, put it in a box, and sent it to us. Then we put it on the computer, and those fish they were caught off coast of Japan after Fukushima. And still we can see, that happened long time back. This was analyzed in 2020, I guess. I analyzed this. You can see high cesium-31 here, cesium-137 here, 661, that's cesium. Lots of potassium.
Lots. Tanashi Bena Japan la Chimbujiani, any tree lab tsunami like the Chungura, and dig up so any Karsure Sota Tidugi Karsure Tinu and Chimbuji Gojao Kerwa. Ani Gojao Keba Maserwa, any di Kora Nanglola, any Sayum that di Kinchene, any Karsure Kerolashi Zay Mangushuji Shordoa. Shor any Kotangbunya Panala draw, the Masal Malhung Yungura, Jasonal Hung, the Leche. Ani Dicheneta, Ko Dinal Hadigre, Tene, Tanda Konzu Taxi Chisa di Nyare, Jabangi, that is Sodabgi, Duzu, Sim. Ani Nyaduzu come ni Konzugi Tajikan Tandoa, and the Gana Korangi the Karsure Yeship Cheba Ins, Jeship Cheba Ins, Jazanta, the Chune, the law Mango Drovarete, Taduyan Duzugi, Lubunang Lola, Keran Shinjing Zet and the cesium, Sumso Dunda, any potassium, and Tuzu Tandu, Tobushuji, any Karsure Jea dos.
And like this was so high, we just ran it for 1 day. Usually we ran the sample for 2 weeks, let it collect data. But this was so high, in 24 hours we got this big peak, which showed, okay, that fish had cesium-137 in it. Now I also mentioned to, oh yeah, sorry, you can translate.
지다이나 콘주기 디 가르스 디니니 케토 망르 용고도 세제라 아니 파게 투자디티라 아니 가르스레 ngobo디 샤네 둔다니 샤그레스 라 아니 단다 radiation 제로 케토디 사주네 다이네 단다디나 추즈니 잡시 낭로라 아니 체토부도 시부지 템바라 디인디 냐도 주기 루부 낭로라다 시즘 야도 숨섭디 망구여바디 아니
And then, as I mentioned, this nuclear fallout, it will spread around the globe, right? So we also collected fish from the west coast of Canada several years after this Fukushima happened, several years after, and still it can show a big signal, like you can see here. This is actually for potassium and this is cesium, yeah.
아니 캐나다기 녀답기 초낭로네 냐수 레네 냐라 따지 주디 냐도 주기 루브낭로래야 아니 숨소드인데나 potassium 체토부 여바직 아니 건조 녀송스.
So I'm showing you this just to give you the introduction to how even if you eat like fish, right, if that was caught from that part of where the nuclear fallout happened, you can have radioactivity in you, right? So if you eat too much of fish, sure, you can develop cancer at some point then.
네, 지난다 고 두주 제 두주 년가 여바다 고 중사디 더 가서로 거자로 중사 타는 부 중바이나야 아니 소설로 슈겐 여바 라 안디리기 제 루보나 여되게 냐도 중아주 망고 사와이나 아주기 루보나로래야 아니 제도주 레빙고레 아니 렙네 콘주기 캐롤라 때는 란주기 루보 최대라 뇌야다 안치기 되네라 소고도주게 차시고레스.
So we take these samples. When they send us this sample, the government sent this sample and we put it on our detectors. So now we will study the radiation detectors.
저도 단단주기 콘주 배천색으로 전시도 주고리운데 아니 콘주기 디 냐다 가리네야 디 아니 파게 뉴체지라 디갈샤 아니 제기여 손자 안단다 뉴체디 콜마 슈빈스.
So how these detectors work and what do we see from these detectors? So let's start. So radiations are measured using radiation detectors. It can provide information like radiation dose of a worker, and worker here means nuclear worker who works in that nuclear power plant, right? When they have to go, they put some batches on them and they try to measure the radioactivity. If it is too high, it will beep. Then they have to come out of that lab. So those are the nuclear workers. So these radiation detectors can tell us information about the radiation dose a worker got while working in that area, or any sample, like Canada government sent us that fish sample, or I can take this rock, right? I can count that also.
저다 단다 개토도 천지 지역이 투자지로와 내가 아니 개토 뉴체 나고라 안디기 아니 오고 천지 지그레스 안디 투자도 저기 내주 가르테기 레슬라바이나 로 아니 코사쿠 투자 회사기 사쿠 데라 개토 망로 여바디 내주 테기 레스 페나차샤바이나다 개토 라신쟁기 아니 제라다 심주치되게 생리바도 저이나 콘조다 딘데 제다 녀보 로고로와 디인디 아니 콘조 낭로라 루부강라 안 투자디 춘주 다요레 이 개토 가져 포기 여바디 아니 천지체네 라 아니 체토부 요나 디게갸네 라 아니 게갸베 값수 데다 사제될 데요 마네 마튼 거와 온데 제야다야 리직 단다다 베나 ngobu 찍라 아니 가르소레 예트 제 가져도 디 천지체야 베나 냐라 천지체라 소바 안 두즈기야 고 디나로라 개토기 제디 가져 여바디 다다 니주 테기 레스.
So some of these detectors will give us information like counts, how many counts of radon atoms or how many counts of uranium atoms. Some of them will give us also spectrum. Spectrum is something like this, like we saw in the fish sample. So this is the spectrum. It tells us, like, based on the energy, some can be mass also. These are called the spectrometers because you can really see the energy of any, like cesium-137. I know that it's 661 keV. If I see a peak here, that means it's cesium-137. So this is called the spectrum.
아니 디나로라다 개로 다 가수레 랑신생기 제로와 아니 가수스여 봐 장가 런더웨이나 레런라 보고도 디 장가디 되야직 야 릭직이 단당 아주 요새기 지체소라 치네 디나로라 아니 바게 개로니 다 바게 제니 수 용되게 여기 누바죠라 누바도 아니 문진체네 아니 리뮤람라 nuba digis yunge di ani tse digis resha rwa nuba ani pena di cha tabu cha shaba ina thukja rejik di ani sizem gya da sum sob dun di ani thanga khazu yoba di dinde ge lamne tyendan chini.
And then there are dosimeters. So this is worn by, as I mentioned, by the nuclear worker when they work on any nuclear site. So we use the term nuclear site, that means some kind of nuclear lab or reactor site. And because we cannot put the person on the detectors and count it, right? So they are wearing these badges that tells us how much radiation they have, absorbed from working in that area, for how much, how long did they work there, everything.
Oh. Yeah, rigchik roa tenda di nyulche rigchik la dosimeters la da dos la na azu thun da ora thun 다 가수레 아니 개트 튠도 가수 아니 포고도 디 천제식이 레스 다 두조이나 건조 권야디레 라 아니 디 망체직 딘데기 내다나로 차례낭에도 저기 컨그레스 권내니 건조 디나로 개로 가수 포고도 라 아니 디기 아니 내주되기레스.
So there are three types of radiation detectors. We have seen that some of the radiation detectors can give only counts, some will give counts and spectrums. Others are batches. But what are these detectors? There are three types: gas-filled radiation detectors, scintillation radiation, and solid-state radiation detectors.
제가 된다디 뉴첼디기 가서는 니주 진단디 찌기 탕가잖아. 지야직 로아직이 단다디 외세기 누베기 체디 동야직 로아 리직 단다 봉다나시 권야진이 숨요로아 다 눈주 가서래 코라난기 꼬바스고래 디 릭숨 용그레스 로아고 차고라고라 자와제단스고래 디 릭숨 용그레스 디날 직디 뉴체 코라나로라 랑수기 칸데바치 랑수 강셰베 니 뉴체 직요레스 Keto Nilse. Then Rigchik, the scintillation, I don't know.
I will teach them. Yeah.
Scintillation, radiation detectors, labgres, and Shambadilla detectors, Lani Rixum, Yores.
So let's go with the gas-filled radiation detectors. These are basically the Geiger-Müller GM counters. All it gives us is counts. No spectrum, just counts whenever a radiation. So it consists of an ionization chamber. Like chamber is like a box. I was trying to make a chamber here, but the chamber really has to be tight. No air should go out or come in. So here I cannot achieve that, but we have special, very professionally made chambers where I can get all the air out. It's at vacuum.
So this is vacuum?
No, I'm just saying that this is a chamber.
Okay.
But we can even, have a chamber with no air or nothing in it. We can pump it out. But this is a chamber which has some gas filled in it. Mainly, I think it's argon gas.
Okay. 제가 단단히 방수 왜 뉴체주라 뉴체디 고바도디 딘데지요 레스 코란 치로라 아니 롬지요 바체 아니 롬디 디 카르스레 치나라 롱 주마투아치 라 치 롱디 나로 투마레 난기 롱디 마트현 투마르와 딘데기 롬지체 안 롬디 낭로라 아니 랑수기 강셰 레스 랑수디 디나로 루에 랑수디 피제 아르곤 차고.
So what happens is when a radiation interacts with the gas molecules in this chamber, what happens is it undergoes ionization. We know the process ionization, so I'm not going to explain again. What happens in ionization is electrons and ion pairs are, electron and positive ion is produced, right?
제가 다 디나 내가 제단디 카르레슬라바 이나로와 롬디체 엔 롬디네네 코 카르스레 케토 아니 코 뇌진이 주사요 바체 아니 케토 나로 주윤디 디 랑수기 엔 두텐다 탑조르시기로와 탑조르시베 두니니 베나 알파기 두이네다 비타기 두이나 코 쿠르융에 로쿠르융에기 두이로와 아니 낭기 엔 랑수기 탑조르체베 값수 아니 양나 코 디네네 록두지 칠부다네 고 제두 소샤그로와 디 아니 카르소레 소기레스.
So then when these electron on ion pairs are formed, the electrons, so in this chamber there is also electrodes. I'm not sure if you know what electrodes are. These are like conductors. In every cell you have positive electrode and negative electrode, right? And positive electrode is anode, negative is cathode. Anode is usually like a wire in the middle here, and cathode is basically just the surface. It is mainly stainless steel in this case or some other metal.
제가 다 디낭로라 아니 기마데라 로코 롬디 낭로라 다 랑수요와 안 기마데라 아니 아주 카르소레 로쿠스 지요레스 아주 남기 롱네 라게와 롱네 포다 모체 안 기기 디 롱네 포잉에 디레 아니 롱네 모체로와 디 롬디 짜기 리기 소샤바체 인디 롱네 모체 디데기 카르소레 아주 로쿠스라 지 롱네 지요레스.
So these electrons, they will move towards, once these electrons and ions are formed, electron goes towards the anode, and the ion, positive ion, move towards the cathode.
제가다 알파 뒤디 코 카르소레 랑수 난기 뒤텐다 탑조체기로 탑조체네 록두지 칠부 땅바이나 록두디 모르와 로쿠르 모인자 아니 데 롱네 포기 로셔레스 데라 디네 록두 된 사회 슐라 계둘 하그와 계두디 포차로와 디네 록두 직 텐사와 순자 포구르 차그와 포구르 인도 코라 롱네 모.
So electron starts drifting here, it gets collected, then it produces an output pulse. When these electrons reach the anode, it produces current, output current, and this is what we have, an output like electric current meter or something. Whenever there is a current, when electron moves here, gets onto the anode, this needle will deflect, telling us there was a count.
데라 롱네 카르소레 록두디 롱네 포데라 드로네 니 디코 카르소레 아주 디로아 덴수로아 데네 로 주도디 디나로라 카르소레 다디라 고조지 땅그로아 고조 땅텐 레라 아니 코디 아주 케트기 디레레 레바디 아니 탕가자.
And some of these counters even have loudspeaker, like speakers. So whenever a count is done, it will beep like tuck, tuck, tuck. Like it will have a click sound. That means there was 1 count, 2 count, 3 count. So these kind of GM counters, like gas-filled detectors, they don't tell us what radiation is coming. All they give us is counts. They don't tell us what was the energy of the radiation. All it gives us is counts.
카시에 투자 카시에 나로라 자감스러지 투요레스와 디인디 롱네 딜라 로 에레 충두장발라 아니 다 타그레스 탁탁탁라니 아니 다 타데 레레기 아니 딘데 게토라시징기 듀 레레 디날 주바디 충교레스와 디기 아니 카리뚱기레스라나 고 게토라시징기 듀 가주요 바 장가디 뚱바레마도 듀기 오 카레
So these are the gas-filled counters. So now, moving on to the scintillation radiation detectors. So these are, it detects and measures the ionizing radiation by using excitation effect. We know what happens in excitation, right? Goes to the excited state, de-excites by releasing a photon. Right, so this is what is happening here. It uses the excitation principle.
다 니버죠라. 가서래 투저릭 니버디 scintillation 라고도와 디낭로라 카리페주치기어레슬라바이나 아니 게다 단다디 게토두주 로디 파게 로 이네 와 아니 가서 록두 직 누바 림바 옹만에 공만에야 포야지요라 포야디 아니 가서래 내다디 표주식이어레스.
So it consists of a scintillating material. So when this light is produced, I need something like to produce that light, right? So these kind of detectors usually have a scintillating material. This scintillating material can be oil like mineral oil, or it can be some kind of powder. It can be in any form, or any crystal.
네. 제가 디 낭로라 아니 콘주기 가르쳐 주식 제직라. So how would you define scintillating in this case? That it would excite multiple
Yes, it will scintillate. Yeah, scintillation is like it will produce scintillation
Multiple
light, scintillation
excitation.
photon, scintillation photon.
Okay. 제가 디 낭로라 아니 콘주기 제 powder 된데 이네다 저 채수 이네다 아니야 가서 눔기릭 된데 샤네라 아니 단데 제디 가르치기 레슬라바이나 코란라 아니 가서 뉴바르 레레 중거와 뉴바르 중화디 아니 체르게 지겨 레스라 체르게 제네 아니 어디 다지게 망부지 기준시에지 아니 지겨 레스.
So I am taking here a sodium iodide crystal, which is sodium iodide crystal. That crystal is a scintillator material. It will produce light when a radiation interacts with that material. So this is a scintillating material.
제가 단다 디 낭로라 배순 디 낭로라 표주시해줘라다 디 아니 소디움 아이오다이드 쓰고도 디게 크리스탈라는 다르술라는 교고라 어디 표주시해 버레스다 코란라 아니 케로직 포네 아니 단당 아주 뉴바르 아니 랑신 젠도 유르베 값수 안딜라테네 왜 기준식이레스.
So what happens is a radiation is coming, right, and it interacts with the sodium iodide crystal, which is a scintillator. Excitation happens. It will give its energy to the electron, right, and then electron goes to the excited state, then comes to the ground state by releasing photons. And these photons then is sensed by something. I need some kind of light detector that can detect that light, right? So that is the photomultiplier tube here.
Okay. 디 다르디나 다르수디 레슬라바이나 아니 코란라다 외도치기 기록이다 가리네 포윤디 때네 아니 코란기다 록두직 누바 공말에 야파게 빠르와체 아니 누바 공만에 마 오말마사디 왜 기준식으로와 디 외계된 제바 디 아니 아코 초르체기 아니 투자신 바지 델샤기요 레스.
So now I have produced a scintillation light here. So when this enters a photomultiplier tube, at the very beginning of this tube there is a photocathode. It's like a metal surface. So photon interacting with material. Think about the photoelectric effect. What happens? Photoelectrons will be created. We just studied, right? Photons will give all its energy to that electron, and electron gets kicked out. Photoelectrons are produced. These photoelectrons then goes out from photocathode, and then they hit these dinodes, which is electron multiplier. One photoelectron goes, many electrons are produced. Again to the second dynode, third dynode. So many electrons are produced, and at the end there is an anode. When this electron reaches the anode, it produces output current.
제가 단다디 지다 인지나로 scintillate 라나 excite 어서러지 고구로와 디 인디 다디 제디 믹스 캐주 가리어 레슬라바이나 콜라 웨포와이나 라니 코란기 록두도 뉴바르기 아니 뉴바야 바르거 뉴바세라 뉴바세 버손자 아니 공말에야 파르 안티네 깝치네 마사인고라디디 외케로와 다 외케바디 아니 가르치기 레슬라바이나 데라 아니 포토 캐토드르도와 가서 외기 롱네 모스라고르베 딘데기 짜지기 요레스라 안데라 포인디 짜디로 외포인디 외로 누난기 아니 디 중바이 외로 니나 중네 와 자디네 아니 록두지 게드치고 록두지 칠부지고 와 아니 왜디기 아니 누바 차상직 록두디라테 아니 록두디 코란 뒤텐레 칠부체버 손자 아니 디 감디 나로라마 게드치기도 와 딘데기 록두디다 감기 모여 가와라 폭바이나야스 모여디 탈라 와 카르소레 부구저라 부구디기 타 창상 아니 카르소레 자소로 지기 까셔 네 자딜라 록두 포라 록두 포바딜라 테네 디기 아니 록두 니 야 니보디 야도 야 디네네 시기 준체 도스도시네 포덴 레레라 록두 마마 기준체네 한 타마 델라 레운두 록두 편천부지 기준체 바로와 안 델라 더 록네 포디오레스 제가 딘데기 록두디 차상지 아니 록네 딜라 포용두 라 아니 록규 기준체 그레스.
So at the end we get output current which we can see on our computer. We will get a pulse every time there was one event. We get light is detected, we get event, like there will be pulse. So with this output current pulse, it can be seen on our computer and it's proportional to the amount of light that entered the PMT. So that current will tell us how much light entered this photocathode, and which is also telling us it's also proportional to the amount of energy entering the scintillator. So what was the energy of that radiation that entered the scintillator? So from here we can really tell what was the energy of the incoming radiation.
That the any karsure ngaju logdu manguchik ra lone podela porwa powadi any ko an senje chene ra ngaju pulse lana da parda soro dirwa dinde any phage tujagi ta toyung res ra any ta logyungi parda jora logyungi any parda 가주 기준 체바 가주 기준 체바디 가릴라 라리기 레슬라바이나 로 디네네 추왜 가주 아니 용구여바 텔라 라리기 레스 안 디데기 왜 가주 용와디 가릴라 라리기 레슬라바이나 디 아니 디나로 수 슈겐기 아니 누바데 레스 누발라 라리기 레스 제자 롱네 타망아주 델라 롱네기 롱네스데 로기 파르다 아니 딜라 때네 와 당보 제로되기 아니 누바 가져임바디 아니 전체체 두고요 레스.
So all it is doing is from the current, right? That current will output pulse will tell us what was the energy. It's just an easy term. What was the energy of the photon and how much current it produced. If it was high energy, it will produce some value of current. Low energy, it will produce some value of current. So that's how we know that that's the energy peak.
제가 로균기 세딜라 아니 가르소레 식네 밖에 당보 수 슝에기 개로디기 누바 가져임바디 아니 지자도고요 레스라 개로기 밖에 뒤이네다 아니 가르소레 외이네다 디기 누바 첨부요나 로두기 세 로두기 파르다기 예전지 용거레스 누바 마요나 야체 마지 용거레스 제가 로두기 파르세죠라 데 파르다기 세 디라 아니 디기 토네 아주 토메 개로기 아니 누바 가져임바디 지투그레스.
So this is how these scintillation detectors work. Now, oops. Here I have used this scintillator material, but we can have different. Here I have a scintillator material. I can pass it around. You can look at it afterwards in the afternoon session. There is a scintillating material which is white powder, and we coated this inside this that attracts the radon gas or something. It will produce scintillation light. So this is zinc sulfide. So there can be different materials. In one of the detectors, Snow Plus detector, which detects neutrinos, we have scintillator which is in the form of oil. So there are different kind of scintillating materials.
tadinalola ko karsure azu barze segoroda ko ya parwar chigengi zejuradi manda yongchogres tanda dela sodium ani iodide darsu de pejucherwa ani the chala bottle jidwa shedam dinanglola ya ani sodium sulfide, what did you say?
No, it's zinc sulfide.
Zinc sulfide.
ZNS.
dinanglola zinc sulfide ani karsure azu chema 요레스 까부지도와 니에 고 외포와이나 외인에다 제토카리나 고 포백값수 고 Korani we getting chiki or rest ra. Dindegi any zedi mida peju chiki or Koranzogi Taji Khana Lola the neutrino change chejura de kapsu num peju chiki rest num rik.
So there are different kinds of PMTs. This is one of the PMT that was used for snow experiment to detect neutrinos. So at the end, this is the front side of the PMTs. At the back, you will have this photocathode and dynode in a tube here. So you just cannot see it, but this is what it looks like. These are really big PMTs. And this is the snow experiment. This is me. I'm standing inside the detector, and you can see there were 10,000 multiplier tubes.
The Koranzo Taji Khana Lola peju the photo multiplier tube photo lana we ra we do multiply lana ko dabge che diche ra tube lana phugu ro chena phugu di nang lo la thongma we chi yong bai ne ya we di dabge che ne mangbu chi go ro ta konju gi di sungya lana maning thadu di sungyo ra maning thadu di ko sungya gi nyul che ta di chi ro di nang lo la gyab gi thanda kharso nga jo Lone moda poda to the segi of my rest ko jabdele your rest ra that deep dinde any 10,000 oh dinde any teaching your rest ra gena koran de do and the nyulchegi any nyulche de karigi tuba rest la baina kharsore we dabgegi bugu slagoro da we do dabge bugu any teaching ki any the nyulche de any so your rest.
So the idea was when a neutrino comes from the sun, inside our detector, it will produce reactions, light will be produced. That light will be detected by these PMTs, and we had 10,000 because neutrinos can come from anywhere. It's a 12-meter ball, like spherical.
So light is produced by the neutrinos? Did you say?
So neutrinos, when they come from the sun, there was, in this detector, there was heavy water. So it will interact with the atom of that heavy water, and it then produces light.
Okay.
That light is then detected by these PMTs.
Okay. The Tajikana Senji Chiejura Tedina Maning Tadul di Che, Maning Tadul is Kawani Yungorlana, Nimani Yungudwa. The Tanda di Tajikan di Nanglolas, Tanda di Nulche, Nuche to Karinangla Yoreslana, Chunala, Chunala Chive Chula Ejura, heavy water, or di Nangla Yores, Chetata, Maning Tadu di Chunala Shune. Chive Chujira dida Dejo Chigra, Dejo Chisabla, any we getting chair Yungu rest, we getting chair the word to any the new chair chicken and lopo you do, and deep palatene, any Konzugi Loki Parta de Sung to your rest.
Oh, this is me. So sometimes these PMTs can go bad because it was immersed in water. So we had to get down in the detector, and then I was fixing some of these PMTs. See, here you can see the dynode sections, like the photocathode and the dynode. The front part is inside the detector. This is the outside of the detector.
Cabreda, the Zutola to any the Mosans and the Udu Dabgegi Pugudu, Shorwaina, and Suju Gagores, Jonathan di Gangi, Nulchet and Gitu Choradi, Yagan Yora, any Koranzo Warni. And Dichigora. Is this heavy water?
Yes.
Okay.
No, this is light water. Sorry, this is light water.
This is light water.
Yeah.
And heavy water is inside?
Inside the detector.
Okay. Nanglo that the Chu Gangdoa, the Jive Chu said, the inner Yundengi Chu the rest.
So now you have seen what the scintillation detectors do. So now solid state radiation detectors, that's the third kind of radiation detectors. So these are basically semiconductor detectors, like the semiconductor diode chips. I think Muchun will be touching little base on semiconductor, how it actually works. No? Okay, good. What happens is, common choice of material is silicon or germanium. It's like a semiconductor diode, which also have electrodes, positive and negative electrodes. So just think about that. It will also produce, it will undergo, so when, let's say a gamma enters enters one of these detectors. So there is a crystal. I have a crystal, germanium crystal. So it's a semiconductor diode. When gamma interacts with the germanium crystal, what it can do, it can undergo all these three processes: photoelectric effect, Compton, or pair production, right? And in all these, we know what happens. Electron and hole pairs are produced. These electrons will go to the positive side, anode, and that produces current. So it's the same basic principle. Just remember photon, what process they go through. And then the output current that is produced will tell us about the energy of the gamma that interacted with the crystal.
Los. Jada di nyulche rig sumba dirwa andila solid state lagudwa radiation detectors. The solid states the texugi any texula never mangu yebanalo never chigwa. Ani that digi nyuche di nalo karipeju chigreslana semiconductors che densu ina tanga siu tema so kanje densu ani kora nedangi wangi kabre logyu tangi or kabre logyu tangi marwa che densu peju chigres ta di nanglo ne che densu ye karsure ze nanglo ne ani shukchewa di germanium tuni khang ro chigi res ani lega chidan di khares la baina ta darsu peju chigi lana ani dirwa karsure ngazo texu imba khangshila di nangi ani duten duzo ra dudul duzo korangi koba ngejen la dedenge gi ani suk duzo la darsu la gyo ra chedan de ji pheju chi gyo res ta de chilo ne pena gama those doji lebaina ani gama those di darsu de la phogrwa phogwala te ne ani tanda di gama gi ngazo karsure pemsula dejo chedan wa ani sumga dinar yungo yo res 라 카르스레 로니나 용거레 컴론다 아니 차드윈도 숨가 용거 레스 안 딘데 숨가 게베 규림라 페나 록두지 게드윈 체바이나 딘데게 록두디 라 카르스레 록두 모르와 모임바 순자 디나 로네 포기 촐로 두구레 아니 코 심발라테네 록두지 게로라 제가 차와 체단지로 디나로 레가 체단디 당기 공다 아니 더우요 레스
So these high purity germanium crystals are only sensitive to gammas, not to alphas and betas. So only gammas can be detected with these kind of detectors. For alphas, we use like semiconductor diode, silicon diode chips.
Oh, so that the germanium like the high purity lana pet tangma shuji he me thinking germanium ge darsu china the gamma those nyambo dejo chikma do shinda those la dejo chikma res ani di nanglo ne da ko gamma those le koran dejo chene lo dwin kigirwa lo dwin chisu kigirwa an di ani karsure lo dwin la shikde an koran gi nebak che tu res ta those geto shimba pena ina ani gamma thanda di germanium gi darsu gi lega chikma res an dila ani silicon gi dar.
So remember yesterday when I was showing you the radon counter, I said it's like a semiconductor diode. It's basic. I think it's silicon diode chip. We have not opened it yet to see what it exactly is. So we have the plan to open and see exactly what kind of chip they have. But we think it's silicon diode chip. So.
Kazang azu de la radon gi nyuche che do di nanglo la pheche silicon yimba yes gyala koran zu da khap ngo mes ngoya gi chashi ye di nanglo la ani chips de khare do di taya ins.
So this is one of the high purity germanium detector we have at Snow Lab, the very first detector we got at Snow Lab. This is the germanium crystal. This you can see it here. This was when it was just brought underground, so you really don't see it's very clean, but now the detector is set up like this. Inside we have copper and then lead.
Oh, tanda di tanda Quran zu ki takche khan li yebe ani germanium gi ta kharsu re nyulche di res ro tanda di ina thongmar ma ki yung we kap su germanium gi darsu di che en darsu di tanda di na lu do wa thodi na lu do wa thodi ni sang gi so wa res en di thala ani shani gi kor sha res.
So we usually shield these detectors. We shield the crystal with copper and then lead. Why? Because lead is there from the walls. I can get gammas, right? So these are the backgrounds. This is not coming from any sample. If I have a sample sitting on top of the crystal to analyze, if I don't shield the detector, there will be gammas from the wall. So I won't get the real value of the sample activity, right?
So that the darsu Quran dirwa di Quran yulwa ko zechik na lola mena chala ro chigi ani keto khasu chigi do mendo tagu yona dinde ki chala di ani ko khaptu digala ani shagi yosarwa ani dine ko keto arike badi ani sone ani dadi khasuret di thala tanda thodi sangi thoda ani thala shani shago ed kharres labaina ani thai ani tsikbada diwani gama those yong digora and duzo kaya ki shagi.
So that's why we shield this from just to shield the gammas coming from the walls itself. But also we have now, you might ask like, okay, lead can shield the gammas from the wall, then why do we have copper shielding also inside, right? So the reason is sometimes this lead itself can produce X-rays. Just think about the process, right? How X-rays are produced, right? Electron gets captured by the nucleus, and then electron from the higher orbit goes to the lower orbit by releasing X-rays. So this lead atom can produce X-rays by itself. That can travel still to this crystal, right? So to shield that X-rays, we have copper here that will shield the X-rays coming from lead.
Taona ani shanye di kharsore ani tsikbada thako ni yongwe gama kaya ki chedu ina ani di sangdi kharjini res labaina ani shanye khora nanglo la yang kabre tanda ngazu tedu gi logdu chu thenya yowa dinde thembe gyurim nanglo la ani logdu ji themba ina di tongchal ha badela nuba khangman nurim khangman ne logdu ma sa ne di shuldu ani kharsun ngazu x thoy gigirwa the extra the any kaya gechedo any sangdi shagi or res.
Now in some of the detectors, the copper can also produce X-rays. To shield that, we sometimes put some plastic material like acrylic material just to shield the X-rays from copper. I think this detector has, but some of our detectors don't have that.
No. The ine ya copper khora nanglo le dinde yong sig res ro. Yimbasunza di sang jora ani sang dini yang kedrin chebe ani kharsore tanda di sungyob chele ya giki an thum dene gugu res cheza di thala ani giki thum dene ani sha.
So any material we receive like a lake water sample or anything, we place that on top of this crystal and then just measure it, and we have the shielding so the backgrounds won't come in. It will just be the sample that produced like that had gammas, so that will give us the true activity of that sample.
Tangazo chala khari gi ta khetyo gi chedi je gu gu yona dinde gi chala ju pena choji gi rwa chu nanglo la khetro je khazu do ta ina chudi ni jingna lu an ne di khapdu de garanga la sha shi res di sha du qur'ani khetro yo ba ina wa an lo ba di an di ni sung tu gu res.
Okay, this we have already shown you the gamma chains. I don't have to. So we have seen the uranium and thorium decay chains yesterday, the gammas coming out from each of those decays. And there are some other isotopes that we look at is potassium-40, which decays to argon, and a gamma of 1460 keV is released. Cesium-137 that we saw in the fish sample after Fukushima, and then cobalt-60, and then these are the gammas emitted from all these isotopes.
제가 가장 아주 더 가마 개토기 디 규림 카직 따로 유레늄 더 토리움 아니 디나신 단다데 포타시움 10주 디단 제네 가마 토세 연구요 레스 아니 포타시움 디 아니 가마 마 르기와 가마 토세 르윤디 디기 누바디 가주레슬라나 누바디 디체 킬로 일렉트론 볼트 직동 10개 tuk주체 안디 레베 오도 아니 가르 potassium khora khari la gyurge reslana argon la gyugudwa anasi CCM gather some subduing the any digi gamma joseph any nuba pagita dembalu yore and jugi dunini ledani yungoda on the chine mida yores.
So this is one of the detector we have at Snow Lab. It's a silicon diode to measure alphas. From any sample, we place a sample inside this or somewhere here, like there is a sample counting here. And the scientist is now trying to acquire the data. So what happens is the alphas will travel, the radon will travel up to this detector, and then there is a silicon diode chip. The alphas then hit this diode and they produce the electron hole pairs, and we finally see the output current. So this is just an example showing you of one of the silicon detectors to detect alphas.
The Karipar race lavaina any silicon yura and silicon gi the diode di nurshegi any parcha the res and dinanglola any zejura di ngobudi de la shagres and tinenia any Karina dinanglol do ani di toserchura dinanglol do nanglola the silicon gi darsuji ra darsu de la pone ani tangi shibe gyurim du chungyo res chungwala tene tama logdai na Karina di gitone ani karsure dul khari imbada dulge nuba khari imbadu zo ani chenje shetugo res.
So like these the radon monitor we have, it will just measure the air quality, right, or the radon levels in that area. But this can measure any material. If someone gives me a camera, I want to see how much radon comes from that camera, because for our experiments, we really care for radioactivity, right? So it's not people will get cancer from that, but for our experiment, we need very less radioactivity. So that's one of the reasons at Snow Lab, we get so many samples to count to look for the radioactivity level, and this is basically telling me how much radon is in there. And these detectors are really very expensive. This is like very cheap, bought from the, that's why it was not able to detect this piece of rock. If I put the same rock in this detector, in 1 hour I will get so many counts. So these are like $11,000 one detector, and there are about 6 detectors here.
Tanda ngazu dela radon gi nyulche chera di gi ta lungkham nala radon khazu do di dunzu ina tanda dela yo dunzu gi chala khari ne di gi ani je chetu res ra chala di dela sha baina yana dela sha ne da nanglo lu chu baina da di che yundi ani chala ne radon chito khazu che ba di ani chei kya tu gu res ra phagi da zu ne kheu res di ra ji ketorang shin jing doji thila shabaine khogi chenji chetukmin do ina duzu tenje gi nuba masuna hajang gi thobuche ra khari ne chala khari tugu res jeza khunju gi taje khanang lo la ani chala mangushu jorgyo res digi keto gi cheshi khazure do cheya an dine chewe tapso duzu pheju chigyo res ani thuja duzu khonchim bu shure re la akor ani chichi chago res.
So we have HPGE counters, which is germanium crystal, and I also mentioned about sodium iodide crystal, right? Both of them look for gammas, and they produce spectrums like these spectrums here. We prefer HPGE counters over NAI, like sodium iodide counters. Why? Because in sodium iodide, when we get this energy, you can see that this red one, the energy resolution is like little bit, I can actually draw it here. From the sodium iodide, what you will see, if you see any peak, you will see some broad peak. With the same sample, if I put on HPGE counters, you will really get a fine peak. Really telling me, and it's easy because if some gammas have, there are 2 gammas very close to each other, it's very hard to detect them sometimes in that spectrum file. But these will produce so thin lines that I can easily, there is one here, one here. So that's why the energy resolution of, it's called energy resolution, how, in easier terms, how cleared out this peak is. So that's why we prefer these kind of detectors.
네. 다 단기 배트니 슈로아 올라 단다 소디움 아이다이기 다르수 배치기도 아 디나로라 저메니엄 라이드 배치기고 어와 다 군인이기 아니 천재 제야디 고 가마토세 가져요 바다 누바 가져요 천재 치고 어와 이나 개발 커리어에 슬라바이나 아 단다 소디움 아이다이기 아니 이게 세부시라 된투 마레스 로 그러나 따지게 가수래 가마 토세 여바디 템바이나야 로아 그 세가시다 매바치네 로아 세가 매바디 파기 리무디 샹가치고 여바디 디기 충겨레스 저메니엄 타우 차샤바이나 공부들에도 공부디 베테 틱디 아니 베테 답다체 로아 디 임보순자 아니 누바니 코 다우로 니부 요나야 디 세가디 아니 저메니엄 디나 퉁그레 소디움 디나 퉁마레스 제자 콘주 코란족에 담가 제디 아니 저메니엄 제디에기 뉴체디 아니 담가 지거레스.
So I just showed you this cobalt. When it decays, two gammas are produced, right? 1173 keV and 1332 keV, two gammas. So what I showed here, this is a cobalt 60 source, right? And you can see the two gammas, 1173 and 1332 keV. So that's how, you know, we can always say, okay, if I see energy peak at, like the peak at this energy, that means it's cobalt 60. And these ones are the X-rays. So some of the X-rays from lead can, I know there is copper shielding, but still some of them can pass through. From the copper also, some of them can pass through and reach the crystal. So this is the background actually. So we don't really look at these because we know that this will be there, the background of the detector. These are just the X-rays, not from the sample.
Oh, 제가 단다 된 알로라 아니 티 그래 링부 니 용고도 아니 군인이기 다 뉴체디면다래도 직들라 직동 아니 직야 든주든 숨체 심바데 직동 숨야 니스타니스라니 디레도.
Sorry?
Okay. Is that the number of counts? Okay.
Yeah.
파조딜라 장가디체 로아 안디닌수 아니 뉴베기 체시디레도 제자다 고발 축주다 부차샤바이나 코나디 가수레 개토기 토네 아니 세규 도윤디 뉴바니 당기 계준치기도 뉴바민도 디니가 안 디나라 세투고로 제자딘데 리모통 남산디 고발 축주네 중샵에 아니 가수레 개토 응지 투부요레스 다 오나 오딜라 아니 지게 가수레 리무질리기도 디 가르스 디 아니 가마 토세 라테네 마레 엑스 토세기 아니 센제 체버드레스 디 엑스 토세디 가니 용거레스라나 고란파게 가수레 개토기 중군디 마임바체네 당기 타네 용거요와 칠로네 직발라 소바도즈 용거레 아니 라야 코 주와텝네 가수레 가조 록디츠 레네 lokbar kigora extra no duzu res cheza di kyapjonggi ani khetro duzu che and di na jungung khoran la ne chungshabe ani khetro dres.
So the gammas you see here are from the photoelectric effect. Full energy is deposited, so we see a huge peak here. So these are from the photoelectric effect, and then the ones here are from Compton effect and pair production. So what is happening is, in Compton effect we know, in pair production, only some of energy of the photon is deposited. So we see, even if photon has high energy, but because it deposits only some part of its energy, so we see these peaks at lower energy, right? So this is actually the Compton thing. And many photons are here, and it's just showing the Compton effect here, or pair production.
네, 다디 천지 지연이 가면은 록디드즈로 시비 당시에 록디디 아니 로네폴 아니 포발에 되는 록윤티네 세제치기로 와. 다 디갑수 록디수설 누바 가수요 바디 디 리모디게 세기도 와. 디갑수이나 갈수레 누바디 직동 야다 든주든 숨 직동 숨겨로 와. 제자다 дү니니 따부 차샤바이나 록디니디 아니 칸디스케레 슬라바이나 외디니난기 토니케레스 어디는 외로 건다 외로는 welo nunang gi keba di khande saku resla ba ina welo nunang na lo la wela nuba khari ba di chacha logdu di la tego orwa cheza logdu di la ra ne che ta dinzu ta logdu kidrin che sha ba du zu ina khonzu nuba mawu ro da wa nuba mawu imba sonza ta du zu khari gi thone yung go resla na komton ani kharsure dananga zo khator dine yung go res kaisna komton gi ani khator gi gyurim din ang lo la 외디지 용에 디 로두라 테베 값수 누바 차sam지 되거라 누바 차상 되고 말아 제가 디 누바 마오 용에 디레스.
So now actually you know what a spectrum will look like for, is that the one? Yeah, what a spectrum would look like. This is not working. Okay, for from a gamma spectroscopy. So this is actually gamma spectroscopy, and this is the photo peak, photoelectric effect, the full energy peak. This is the Compton, right? And this is from pair production. And how I know this is from pair production, not Compton? I see a peak at 511. Remember, at the end of pair production, actually this is actually annihilation. When annihilation happens, two gammas are produced each with energy of 511, so that's how I know this is from the annihilation process. So this is how you read these kind of spectrums.
That the remote di ni gamma shell remote la korwa chagi res chesa gamma wedi yong ne ani phage kharsure darsu la danger che chebal de lodu ki girwa lodu ke ba di ani kharsure nga zo longne phola do ne nga zo simgirwa simne ani remote di thungorwa ani remote di na la penandi ta bucha shabaina ro nuba masuna nuba di ani kharsure che thobu yinza ro di ani velo nunal te ne chungsha bache ta pena remote di ta bucha shabaina di khaptu de la nga zo che ji le doa che di nuba khajure de la na ngapje chukji re doa ro nuba ngapje chukji yesa gi chamla che ji le doa ta di remote di le nga zo khari haku ku resla baina dinregi logyun chira logyun kekhendi kharila teni ke baresla na kharsura annihilation kharsur nga logdu phoda logdu mo ni thene thebe kapsu khuni ni zadong rugu yo ba gyun che dora dinene ani gamma those ni ki gi yo ba dinregi gamma those ni de la nuba khaso yo resla baina nuba di tangi genla sungsa lego cha nga khare chik sungsa on dinregi gi ani logdu di adi logdu la kene en logdu di ani suyun di an logdu de la nuba di gesio res ra chesa di rimu di la tene ra an di nanglo la kharsore logdu ki drin che di kharila tene ke ki drin chesha di ani ngunzi che tu res.
And in the annihilation, two gammas are produced, right? 511. So sometimes one of that gamma will interact, will be absorbed, the other one will just go out of the detector. Sometimes both the gammas will be absorbed, they will transfer their energy, and then both will be absorbed. So that's why sometimes we can also see peaks here. This is when one of the gamma was absorbed fully and the other one escaped. So how I will know that this is the single peak? The full photoelectric effect energy, let's say whatever the value was, minus 511. So if I get a peak from that energy minus 511, that means one of the peak escaped and only one was here, it got absorbed. If I get at like the full energy, the photo peak energy minus 511 times 2 is 1022. So if I see something at this value, that means both the photons did not even interact, they just left the detector. So sometimes you can see peaks here, but these are not from the sample. This is just like telling. These are basically, actually we look at these photo peaks to tell what type of photon was that.
Los. Jezanda pena chadungi negapsura duini tungura logdu poda logdu mo kunini penzu tu yundu ari nubeng ol rosharwa nubadila nuba rigni yunguwa gamma rigni ta gamma rigniga nigagi ani kora tanda darsu nanglo la 아니 로드라 체네 로드라 아니 누바 가서래 로드 칠부 땅에 지기 용거레스 딘데 땅에 값수 라 가서 아니 디 네모디 통고도와 따이네 가만히 나로 찍기 아니 로드라 대조체 아니 심바디 디네네 튼도와이나 라 다 아니 디 네값수 가서 빅 디 통고레스 네모디 라 따디 임바디 칸레스 사바이나 코란기 아니 가서래 외로 누나 중바이나 누바 차산되고라 딘데기 내다라 누바 가져임바디 직센지체 라 안 디낭로네 밖에 납제 죽지마 템베 텐사 참데라 아니 빅직 용고요나 제모지 용고요나 아니 가마니기 나로 직 아니 쇼더 직디기 아니 로드 이케린체 레스 다야 단다디 가서래 외뒤 차산 누바 차산 디네네 라 죽지 니기 가져래 아니 직동이 산이로와 군인이 템베 누가 디네네 아니 직동이 산이 템베 참데라 아니 네모지여나 아니 디갑수 가마토세 니가 아니 튼도르다 로드 이케르 마체바디 중교 레스체 너무 딘데기 토네 아니 가르가르 중바디 가족이 수지체 두고 어레스
This can be too much information for you, even if you don't understand. That's okay for now, but even sometimes we can make mistakes interpreting the data. So I don't expect you to fully understand it. It's okay even if you understand like just few percentage of that.
제가 디 지진의 뉴지 배편첨부 차바 인식이레스 향주 차사 망에네 교요 말레스 코란주 세리바 나로레 데 딘데 리몰 타네 아니 코 튼데 체인도 튼데 노와 야긴 요레스 제가 넘버 2기 디 뉴지 차사 지 망에네 아니 교요 말레스
When we work in this line like for years and years, that's how you practice. When every day you're analyzing data, that's when you will see, right? Like if you practice math every day, you will be really good in math, but I guess you don't practice, that much, right? So it's just practice makes the man perfect. So it's okay if you don't understand this for now.
레다디 딘데지기 여바디 케나 디고 레스타 14구 다 녜야딜라 뒤저 고르그레스 라 게나 코란스 차샤바이나 로망보직다 다가랑 갈라 아니 심주 제 예십세 딘데치네 아니 고 융아 차데 로스 아니 고 롭센 카리네 롭센 코란 가족이 디디 콜라 델라 아니 레라와다 야가 융구로 와스
So this is just an example of no much information. I'm just showing here a detector spectrum when we did not put the lead shield and copper shield and when we put the shield. So you can see here, this was no shielding was there. So gammas from the wall was also coming. So look at that, how many peaks I see here. So many gammas from the walls are coming and this is just shielding in place. So it reduced. So that's why we prefer to have shields.
아니 탈라 아니 샤니다들에게 가족에 딱할로 탑소라디 예배값다 매배값기 개발레스라 뭐부디 아니 매배값이나 라 안데 제모들의 망고지 용고도아 디 제모도 저기 가르쳐준게레스라나 가마토셀 망고시 우직 라 디인자 샘플 지오라 딱지 치사 딱자디 점 많이 봐 7월에 아니 망고시 우직 용고 여바디 저기 청교레스 제가 딘데 카르소레 수르기 탑디 매백값수 아니 리모딘데지 튕기도와 데네 탑디 매백값수 아니 오기 마부디 아니 개바 친구도 왔어.
Should we stop here or what would you say?
Yeah.
We can stop here?
Yeah.
Yeah, then I can show them about the other read on monitor. So
Sure.
after the break then, right? After
Okay.
that, yeah. It's too much information maybe for them. Just relax.
They
will all be dreaming about radiation now, I guess. So let them absorb that. Okay, so we will meet in the afternoon. And please download that Interspec spectrum.
제가 다 진짜 될 tru기 is 아니 당기 견라기 년체직 마파블리 나로시 슬라이드와 디 넘버 2기 아니 나로나스 아니 치료 추주 된다 체가라 될 좀해로 디디 넘버 2 티와이나 티와 카리네 남페로체스